Hello everyone, how are you all doing tonight? Hello Jasper. Ooh, that is very reactive. Well, just a second. Okay, there. Still a bit, yeah, disconnect. I'm messing around with a few new, like, things for tracking and such, so might be just a bit, different for a little. So get sorted soonish. But yeah, hello Jasper, Huge Blank, Non, Sunrush, is good to see all of you. Dio's Rust before Rust was cool, yeah. I am very excited about what I'm gonna be doing tonight. Gonna be fun, gonna be cool. Yeah, I'm gonna be learning the D programming language. It is gonna be neat, gonna be cool. I've had, I love a lot of the ideas D incorporated. I have had a bunch of folks recommend it to me, so, you know what? I'm gonna give it a shot. Yeah, that's gonna be fun. Other things to talk about today, I did end up making the decision to delay BlanketCon, or really, not just I, but like the BlanketCon team. We've just decided to push it back a couple of weeks because we weren't ready. Still gonna go on, just gonna be a bit later. We want to see how, well, all shakes out and everything, but yeah, there was another interesting thing I saw earlier today. There is a new game that came out yesterday/today. It is called Ctfe Manager. I'm gonna turn this into a series of just learning a bunch of system languages. Honestly, maybe? I'm not sure. Yeah, I think that would honestly be like pretty fun. Honestly, that would be pretty fun to do. That sounds like want to manage Ctfe. There's an interesting thing with the game. At the end of the trailer, they show off, one more, animal. Let me pull up a picture of it. Yeah, they show one more cat right after, like, they show off the title and such. And, well, yeah, that's Llama. It's just Llama. Yeah, it is just Llama. Like, I need to emphasize, I am not associated with this group at all. I legit had not heard about the game until, like, the release trailer went out today. And, there's just a cat that is absolutely a llama cat in it. I'm allergic to cats, can't cuddle anymore. Oh. Well, I mean, it doesn't, do you see any cat hair on that one? I don't. Yeah, this is a delightful cat. I guess I'm gonna be playing this game on stream. RoboCat, like, this is, I believe, completely coincidental. I have never met or heard of any of the folks who worked on it, and it is just a little bit funny and surprising. Anyway, I am really excited to learn D. It is very interesting language. It is, like, yeah, also, oh, yeah, Jasper? Oh, yeah, what's up? Yeah, just like, yep, you're cute, that's all, bye. Oh, thank you. Yeah, C is a really interesting language. It is kind of like in the C or C++ vein, but, you know, better. Yeah, I am very excited to give a look at it. They've got like a whole like tour through D and such. Yeah. So I'm just gonna generally go through that. It's got its ups and downs. Yeah, just like any language. Yeah. I'm just gonna like go through like the tour they've got on their site. It's got like built-in like code samples and everything too. So yeah, I am very excited for that. So how about we get going? There. Alright. Here we are. Particularly fond of contractual programming in the template system in D. Can't wait to give that mascot. Yeah, this mascot is a delight. He's just a guy. Just a guy. Just hanging out. Yeah, So, this tour gives an overview of this powerful and expressive language which compiles directly to efficient native machine code. Clippy but D. D is the culmination of decades of experience implementing compilers for many diverse languages and has a unique set of features. High-level constructs for great modeling power, a high-performance compiled language, static typing, direct interface to the operating system's APIs and hardware, blazingly fast compile times, a memory-safe subset, maintainable easy-to-understand code, a gradual learning curve with C-style syntax, compatible with the C ABI, limited compatibility with the C++ ABI, multi-paradigm with imperative, structured, OO, generic, functional programming, purity, and even assembly, and built-in error detection with contracts and unit tests, along with more. Alright, each section comes with a source code example that can be modified and used to experiment with language features. Click Run or Control-Enter to compile and run. Alright. So like, for example, click. And here we are, yep. Got bright line hello world. Example for experienced programmers, take 3 arrays and without allocating any new memory, sort across all the arrays in place. That's a fun one. Yeah, On we go. Yep. Available multiple languages, I'll be picking English, but yeah. So, yep. Got download, sort chain and such, yeah. Right, so downloads page for various D impls. Yep, there's D language reference compiler, digital Mars D. Then they've got an LLVM one, a GCC one, and more. But yeah, if you're new to D and aren't sure which to install DMD. All right. Yeah. Contains links to pre-built OS-specific DMD packages. Yep. Install script for OS-specific packages for POSIX. Then support for editors. Yeah. The beauty about D is you don't need a fancy IDE, as boilerplate code is very rare. However, using D is nicer when you're in the comfortable zone of your favorite editor. There are D plugins for Atom, Eclipse, Emacs, IntelliJ, Sublime Text, Vim, VS Code, and Visual Studio, as well as a D dedicated IDE. That sure is a dedicated IDE. Yeah, Yeah, you can tell this is not a new language. But yeah, that's absolutely not a bad thing. I want to look into this on our own time, TBH. Ooh, nice. Yeah. I should, in the background, I'm just gonna, like, pop a, I think I'm gonna download both, like, DMD and Yeah, and LDC. Yeah. Okay. Yeah, he's fairly old at this point, so never really got established among the system programmers' lexicon. Oh well, yeah. Oh, thank you for the posture check. Ah. Hey. Yeah. Ah. Yeah, no, having, like, an LLVM decompiler is nice for WASM purposes. Yeah. Alright. Love you. Road's gonna head off for now. Love you. See ya. Sunroses, love you. Yeah, okay. The advent of LDC's made it much more accessible, yeah. Alright, many options allow you to modify the behavior of DMD, yep. So, yep. Command line arguments, comes with package manager and script-like run tool, yep. The helper tool RDMD distributed with DMD compiler will also make sure to compile all dependencies and automatically runs. Nice. Yep. Can be put on the first line of an executable D file to allow script-like usage. Okay. Ooh, Jasper, thank you for gifting a gift sub to Sunroses. Yeah. Yep. Then we've got Dub, standard package manager. Yep. Local install and such. Yep. Running inside this folder will fetch all deps, compile app, and run it. Okay, dub build will compile the project. Alright. It can also be browsed through Dub's web interface. Basically just like, yeah, it's basically just a pretty standard package manager, it looks. Yeah. Hey, imports and modules. One of D's core design decisions was to be consistent and avoid corner cases in the language. This is called turtles all the way down. I see. One good example for this consistency are imports. Yeah. Yep. For a simple Hello World program in D, imports are needed. Yep. Import statement makes all public functions and types from the given module available. An import does not need to appear at the top of a source file. It can also be used locally within functions or any other scope. In the following chapters, you'll see that this applies to almost all concepts in D. The language doesn't impose arbitrary restrictions on you. That's neat. Yeah. So you can do like, yep, so Phobos is the, yep, standard lib, okay. Yep. So that is just your, like, standard STD acronym, okay. Lots of stuff. Okay. Modules are referenced through import standard.module, yep. Also used to selectively import certain symbols, so, like, that would import, like, specifically right line and right format line, yeah. Okay. Let me... Yeah. Import, yep. Selective imports can be used to improve readability by making it obvious where a symbol comes from, and also as a way to prevent clashing of symbols with the same name from different modules. That's good! That fucking blows in Java! D's module system is entirely based on files. For example, my.cat always refers to a file cat.d. Folder my needs to be in the current working directory or in one of the explicitly specified directory imports, and to ease splitting big modules into smaller files, a folder cat could be used as well. Then it would try to load package.d instead of cat.d, okay? Not the convention, but not a hard rule for package.d is to publicly import all other modules in the same folder. Okay, I'll just like do your hello world, yeah. Alright. Basic types. Okay, always have the same side regardless of the platform, yep. Real, which is the highest possible floating point precision, okay. Yeah. Intel, what the fuck are you doing? Intel. Yeah, we got bool, byte, u byte, car, short, u short, w car, word car, Selective imports the solution to Java's janky static imports. Kind of? Yeah. That's part of, yeah, selective imports are the solution to import static, yeah. Alright, then, yeah, then we've also got float, double, and real. Greater than or equal to 64-bit, generally 64-bit, but 80-bit on Intel x86 32-bit. Intel, what the fuck? Ah. Ah. You know what? Like a text source. Then... Hey. Outline. There. Okay. Alright, that's better. Or no, actually, no. I have a better idea for this. There. Better. Why is Snip not displaying again? Come on. Something is wrong with my, like, now playing display thing. And it's annoying. I'll figure it out at some point, but yeah. Thanks, Intel. Yeah. So U denotes unsigned types. Car translates to UTF-8 characters. WCAR used in UTF-16 and DCAR in UTF-32. Okay. Then... Oh, thank you for lurking, Catton. Good to see you. Looking forward to that incrementing, yeah. Conversion to another type may be forced using cast type my var. Okay. You know what? That's not the worst cast syntax I've ever seen. That is definitely not the worst cast syntax I've ever seen. That's not saying much, but yeah. Okay. Right, so yep. Needs to be used with great care. Allowed to break the type system. Don't do that. Special keyword auto creates a variable and infers its type from the right-hand side of the expression. So auto myvar equals 7 will deduce type int. For myvar, note type is still set at compile time and can't be changed. Okay. That is just a type inference. Okay. Alright. They've all got size of and such. Okay. Init. Ooh, they've got inits. Okay. Ooh. Okay. That's cool. Alright. Yeah. Alright. It's good that it's got, like, a specific thing for types to have init values. I like that. Okay. Can you add more data types? That's a good question. More data types are usually helpful. Yeah. Alright, so yeah. Property init to which they're initialized. Integral and floating point types have a max property for the highest value they can represent. Integral types also have a min for the lowest they can represent, whereas floating points have a min normal defined to the smallest representable normalized value that's not 0. Floating point types also have properties nan, infinity, dig, which is digital or decimal digits of precisions, ant dig, number of bits in the mantissa, and more. Okay. Every type also has a string of, which yields its name as string. Got it, yeah. Indeed, indexes usually have alias type size t, which is a type that's large enough to represent an offset into all addressable memory. So that's uint for 32-bit and ulong for 64-bit. Okay, yeah, pretty normal. Assert is an expression with, which verifies conditions in debug mode and aborts with an assertion error if it fails. Assert 0 is used to mark unreachable code. Okay. Yeah, yeah. The way unreachable works in... the way unreachable works in, like, ANSI and such is interesting. Yeah, yeah, like, init and such, that's cool, okay. Yeah, int min, int max, then... What about right ln float dot... What was it that it said it has? There is, min normal, okay. In normal. What are you? Float. Oh. Yeah, 1.17549 E minus 38. Yep. Sounds about right. Yeah. Okay. Memory. C is a system programming language and thus allows normal memory management. However, manual memory management is very error-prone and thus C uses a garbage collector by default to manage memory alloc. Okay, yep. Yeah, we've got, like, pointer types. Okay, yeah. A new memory block on the heap is allocated using the new expression, which returns the pointer to the managed memory. Notice the memory referenced by A isn't referenced anymore through any variable in the program. GC will free it, yep. There are 3 security levels for functions: at system, at trusted, and at safe. Unless specified otherwise, the default is at system. At safe is a subset of D that prevents memory bugs by design. At safe code can only call other at safe or at trusted functions. Moreover, explicit pointer arithmetic is forbidden in at safe code. Alright. Can't do pointer arithmetic in safe. That's fair. Borrow checking is hard, but yeah. At trusted or manually verified functions that allow a bridge between safe D and the dirty, underlying dirty low-level world. Okay, yeah. I think trusted is a better term than... Yeah. I think trusted is a better term than unsafe in most cases, but yeah, Right, mutability. D is a statically typed language. Once a variable has been declared, its type can't be changed from that point onwards. This allows the compiler to prevent bugs early and enforce restrictions at compile time. Good type safety provides the support one needs to make large programs safer and more maintainable. There are several type qualifiers in D, but the most used ones are const and immutable. Alright. Yep. Which are different. Yeah, D provides, yep. An immutable object can only be initialized once and after that isn't allowed to change. Okay. Thus can safely be shared among different threads with no sync because they never change by def. Hey! Yeah. Oh, Jasper, oh, what are you? Oh, you're sharing emotes. Oh, cute. Looks like I'm trying to hug you with this emote combo. Oh, adorable. I did get to set my macro pad. That's a thing I gotta do every single time. Immutable objects can be safely shared among threads. Also implies immutable objects can be cached perfectly. Nice! Const objects can't be modified too. This restriction is just valid for the current scope. Okay. So a const pointer can be created from either a mutable or immutable object. This means that the object is const for your current scope, but someone else might modify it from a different context. Oh, okay. Sure, yeah. Alright. Common for APIs to accept const arguments to ensure they don't modify the input, as that allows the same function to process both mutable and immutable data. That is neat. I think that's cool. Very cool. Yeah. 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 Right. Both immutable and const are transitive, which ensures that once const is applied, it applies recursively to every subcomponent. Got it. Yeah, let's see what's going on here. So, yep, mutable, yep. Yep. Ritalin, yep. Then we can do that. Reassign just fine, yep. Yeah, alright. And, yep, pointer to mutable memory here, yep. Const int pointer, yep. Const pointer to mutable memory is allowed, okay. So const can't be modified itself. That would error. Yeah. But you could, yeah. Alright. Yeah. So that means, like, you can't, like, deref and reassign, yep. As a mutable is guaranteed to stay unchanged, it can't point to mutable memory. So yeah, mutable int im equals andm, yep. Yeah. Pointing to read-only memory, yep. Is 100, yep. Const may point to read-only memory, but it is read-only as well, okay. Alright. Makes sense. Got it. Yeah. Control flow. An application's flow can be controlled conditionally with if and else statements, okay. I see. Okay. I think... Yeah, I understand what's going on here. Because it hasn't been terminated yet, that all count... This is all technically, like, one line as much as the compiler cares. So, yeah. Yep. Pretty standard, like, if-else, everything, switch case, normal jazz. Yep. Equal, not equal, less, greater, or less equal... greater, equal. Then you've got logical or, logical and, switch case, yep, alright. Pretty basic, okay. Functions! Alright, standard still C syntax, okay. Ooh, autos! You can auto returns! If the return type is defined as auto, infers return type automatically, hence multiple return statements must return values with compatible types. Ooh, that's a nice one. Okay. Alright. May define default arguments, yep, just by doing that. Just equals and such, yep. Following arguments must be default as well. Alright. Local funcs. Functions may be declared inside of other functions, where they may be used locally and aren't visible to the outside world. These functions can even have access to objects that are local to the parent scope. The only other time I've seen this in Python where you use it to have, like, a basic encapsulation system without having an encapsulation system. So I hope D has an actually good reason to use them. Because IMO, like, the primary advantage for functions within functions is encapsulation. And I feel like a lot of the time you don't really need to have, yeah. Like, yeah. It can make code neater, but ultimately, like, I'd prefer real encapsulation. Yeah. Alright. They've got some, like, they do have, like, bigger book on D. Alright, yeah. Basically just like a bigger book, okay. Yeah. Alright. So then this will just like, yep. This defines add sub null div. Yep. Then generates a number between start and end where end is not inclusive. Yeah, uniform, yep. Alright, depending on result, we can call one of the ops, yep. So, yeah. Right, uniform is just a form of standard lambda. Alright. I guess it's just always gonna do the divide? Yeah, because it's doing remote service and caching and such. Okay. Structs. Alright. Alright, structs. Pretty basic. Okay. So you got your double X, Y, Z, yeah, standard sort of thing. Then you've got, what does const do there? Constructed on the stack unless created with new and are copied by value. Alright. When a new object of a struct type is created, its members can be initialized in the order they're defined in the struct. Okay. Yep. If a member function is declared with const, it won't be allowed to modify any of its members. Okay. That's a compiler enforce. Makes it callable on any const or immutable object, but also guarantees to callers that the member function will never change the state. Okay. That's cool. So basically that means, hey, don't worry, we don't have side effects. Alright, cool. Bitsniff. Might need to grab some allergy meds. Then beep. Beep. So yeah. I think it is, very cool that the new keyword is... looking through this, I like how the new keyword, means heap allocation and... Sorry, throat being a bit weird. I'm good. Alright. Yeah. I like how new is heap allocation always, and you can, like, call without new for stack allocation. That's cool as shit. That's a delightful language feature. Yep. Any number of member functions, by default public and accessible from outside, could also be private and thus only be callable by other... Alright, so it does have real encapsulation. Thank God! Yeah. Yep. Constant member functions and static member functions, it'll be callable without an instantiated object. Yep. So basically just like static and anything else. Get hosted here. No, thank you, Jasper. Yeah. Struct can't inherit from another struct. Hierarchies of types can only be built using classes, which we'll see later. Okay, yep. However, with alias, this, or mixins, one can easily achieve polymorphic inheritance. Okay. So there's type classes. Nice. Alright. Given the struct vector 3, implement the following functions and make the example application run successfully. Alright, so... Alright, yeah, let's do that. So, return length, dot product to two vectors, a two string, alright? Yeah. Okay. Yep, you can, just, like, do, like, standard printf syntax, okay. So, alright, so it wants to implement, okay. Alright, so vec1. How do I... Fuck. I don't remember. Oh boy. Oh, this is... Alright, so... Alright, yeah. Dot product is just multiply the, yeah. Yeah, so dot product is just, okay, yeah. So, turn, what does it use for internal? This, okay, so that would be this dot x times RHS dot x plus this dot y times RHS dot y plus this dot z times RHS dot z. That'd be that, then, yeah, so that's dot product, then, if a member function has no parameters, the calling braces may be omitted. Ooh! That's neat! Okay, sure, yeah. Yeah. Alright, so, yeah, so length is, that's interesting, yeah, so length for a, alright, so, yeah. How do you do, a 3-vector length? So that is, yeah, so that is one. I know how to do this in 2 dimensions. I don't know how to do it in 3. I know how to do it in 3, I think. So, flat equals, double flat equals, or I can auto flat equals vert, x 2 plus y 2. That's how you do exponents in C-Cell, yeah? Pretty sure. And... alright, so that's one side of it. Alright, then... then you can, actually, no, wait, no. I can't... yeah, D doesn't support Python, so... oh, it doesn't? Oh, hi, Emmy, by the way. So... times x, I, times y. Would it just be, would it just be for plus z times z? Is that it? Is that it? Run. Waiting. I think the assertion's passed, so yeah. Looks it, yay! Ah. Arrays! There are 2 types of arrays, static and dynamic. Access to arrays of any kind is bounds checked. Except when the compiler can prove bounds checks aren't necessary. The fail bounds check yields a range error, which aborts. The Brave can disable this safety feature with the compiler flag bounds check equals off in order to gain speed improvements at the cost of safety. Okay. Alright, so, yep. Static arrays are stored on the stack if defined inside of a function or in static memory otherwise. They have a fixed compile time known length. Arrays type includes the fixed size. Alright, I like that. Okay. R's type is int 8. Note the size of the array is denoted next to the type and not after the variable name, like in C++. I like that. I like having the array size, the array as part of the type, instead of it just being like super glued onto pointers. Dynamic arrays are stored on the heap and can be expanded or shrunk at runtime. Dynamic arrays created using new. Okay. Alright, so... trailing commas. Alright, fine. I don't like how trailing commas look in things. It just doesn't look good to me. I don't like when it's part of the default code style, which it is in too many languages, which for me means more than 0. Yeah, yeah. Again, like, this is, like, I like how the new keyword is just your universal keyword for heap alloc. That's really good. That's genuinely great. Slice your views on a contiguous block of memory and will be explained more in detail in the next section. Got it. Yep, typefars in slice, yeah. Okay. Multi-dim arrays can be created easily using auto r equals new and 3.3. Yep, got it. Can be concatenated using tilde. We'll create a new dynamic array. Okay. Mathematical options can be applied to whole arrays using a C or a syntax. Ooh. Up there. My chair accidentally caught my headphone cable, but yeah. So yeah, C array equals A array plus B array. Yep. All right. Adds all elements of A and B so that CO is AO plus BO. Yep. Also possible to perform operations on a whole array with a single value. Neat. That is cool. Okay. Might be optimized by the compiler to use special processor instructions that do the operations in one go. Poggers. Both static and dynamic arrays provide .length, which is read-only for static arrays, but can be used in the case of dynamic arrays to change its size dynamically. Property.dupe creates a copy of the array. Okay. When indexing through our IDX, yeah, a special $ symbol denotes an array's length. So, okay. Alright, yeah. $-1, yeah. Okay. Sounds good. Alright, exercise complete. Encrypt to use the secret... to encrypt the secret message. Should be encrypted using a Caesar cipher. Okay, yep. Shifts characters alphabet using a certain index. That to be encrypted text only contains characters in A to Z, which should make things easier. Alright, so yeah. Put plus equals 16. There. Would that do it? Or not 16, shift. Run. Oh. Oh yeah, you've got to mark the down. Alright, so you've got to mark that to, like, tell it to apply all over. Got it. Assertion failure! Oh yeah, input plus equal 6? No, modulo. Yeah. Right, so I don't know how. Alright, I'm doing something wrong, but yeah, so, no, result. Run. Right, Unicode values, yeah, Modulo not aligned to A, yeah. Yeah, no, I know what the problem is. I'm trying to figure out how to fix that, yeah. Yeah, oh yeah. You just do like, yeah, like that. Waiting. I put that second quote in. Well. Insertion failure, yep. Yeah. Yeah, let me, yeah. This is more, yeah, like just, alright, what's the, array example Caesar isn't well suited. Wee! Okay. Alright. Okay, so that's... Try aligning the A to 0 modulo 26 like you wanted. Yeah. Alright. Yeah. That's a good result. Yeah. So they're saying... Yeah, so that would be... result minus equals A... No, minus equals A, then result plus equals shift, then result mod equals 26, then result plus equals A, and run. Yay! Good. That's better, yeah. That's just like a text is weird. It should be, yeah. Slices are objects from type T for any given type T, or T-bracket for any given type T, yep. Slices provide a view on a subset of an array of T values, or just point to the whole array. Slices and dynamic arrays are the same, but they're not pointers. They're different, and that's what makes D better than C. Yeah. Two members, a pointer to the starting element, and the length of the slice. Yeah, that's the difference. Getting a slice via new allocation, yep. That'll, yeah. New dynamic arrays created, a slice of this freshly allocated memory is returned. Awesome. Alright, actual allocated memory in this case is completely managed by the GC. Return slice acts as a view on underlying elements. Okay. Alright, so... Yep, then you can slice to existing memory, yep, just by doing like, yep, start end, yep, inclusive, exclusive, yep. Yeah. Very cool. Yep. Also, yep, slice pointing to existing memory, yep. Slicing is very nice. Such slices generate a new view on existing memory. They don't create the new copy. No slice holds a reference to that memory anymore, or a slice part of it, it'll be freed. Yep. Alright, using slices, it's possible to write very efficient code for things like parsers that only operate on one memory block, and slice only the parts they really need to work on. In this way, there's no need to allocate new memory. Yay. Dollar expression is shorthand form for array.length, hence array dollar indexes the element one past slice's end and would generate a range error. Right, if bounce checking hasn't been disabled. Okay, yeah. Basically, standard slicing and such, it's good. Slicing is good. Alias and strings. Oh boy, strings. Now that we know what arrays are, have gotten in touch with Immutable and had a quick look at the basic types. Two new constructs. Alias string equals immutable car array. Oh boy! Term string is defined by an alias, which defines it as a slice of immutable cars. This means once a string has been constructed, its content will never change again. Welcome to UTF-8 string. Wee! Due to their mutability, strings can be shared perfectly among different threads. Nice! As strings, the slice parts can be taken out of it without allocating. Standard function, standard algorithm splitter. Yep. For example, split string by new line without any memory allocations. Neat. Besides UTF-8, there are two more types. There's W string and D string for UTF-16 and 32. Variants are most easily converted to each other using 2 from standard conv. Yep. That means a plain string is defined as an array of 8-bit Unicode code units. All array ops can be used on strings, but they'll work on a code unit level and not a character level. At the same time, standard library algorithms will interpret strings as sequences of code points, and there's also an option to treat them as sequences of graphemes. Unicode graphemes. Basically, yeah. Just, language is fun, and Unicode is the best attempt to deal with it. Yeah. Yep, you can just use 2. What's that bang there for? What is that bang? I just noticed it. What does it mean? I'm worried. Small example illustrates difference in interpretation. Yep. Yeah. Bang indicates template args. Okay, got it. Yeah, bangs are interesting in languages. Yeah. Actual array length of S is 3 because it contains 3 code units. Yep. 41, 03, and 08. Yep. Ladder 2 define a single code point, and walk length counts 2 code points total because there's 2 characters. Yep. By grapheme performs rather expensive calculations to recognize these 2 code points combined into a single displayed character. Okay. Alright. Correct processing of Unicode can be very complicated. Yeah, 2 bang int 2 means that int is the template arg, 2 is the real arg. Friends for template args can be dropped if you only provide 1. Nice. Yeah. Very good, yeah. Simply consider string variables as magical byte arrays and rely on standard lib algorithms to do the right job. If by element iteration is desired, one can use by code unit. Okay. Yeah. Unicode gems. Are gems? What are gems just like package type, or? Yeah, because I know Ruby uses the name gems for its packages. Right. Strings in D can always span over multiple lines. Pogger. WYSIWYG strings. Alright, oh, just raw strings. Okay, yeah. And here doc strings. Okay. Delimited strings. Alright, yep. Okay, yep. Alright, start with Q. Okay. Alright. Interesting. Yep. Yeah. Yep. Minimize laborious escaping reserved symbols. Raw strings can be declared either using backticks or the raw prefix. Okay, yeah. Hooray! Backticks in something. That's cool. I don't see backticks used in programming languages much. Yep. Even more ways to represent string literals. Let's see, yep. All sorts of things. Fun. Okay. Yeah, what are you doing here? Alright. Generate string using printf-like syntax. Yep, D allows native UTF string handling. Poggers. Okay, yep. Then code unit count, code point count, grapheme count. Yep. Strings are just normal arrays, so any operation that works on arrays works here too. Nice. Very cool. And that'll just, like, do things nicely. Okay. Neat. Loops. Alright, we got your while, we got your do while, we got your classic for, we got your for each, okay. Special keywords and labels. Nice. Alright, yep, continue starts next loop iteration. Alright. Pretty standard loops. Alright, yeah, that'll just do your, like, loop stuff. Okay. Ah. For each. Yep. Yeah, iterates over the... Yep. Given an array, type in. Yep. First parameter is the variable name, then semicolon. Yeah, so... Yeah, alright. And it'll, like, just auto-infer. Got it. Nice. I like that for each syntax. You can access by reference with ref, tool. Yep, because otherwise it'll copy from array range during iteration. But yeah, iterate n times. That's just basically put a slice there. Yeah. Iteration with index counter. Yep. Alright. Yeah, if you have two arguments, first will be indexed, then the element. Okay, yep. For each reverse with reverse iteration. Lots of cool stuff. Okay, I like these iteration options. Very nice. I am gonna be back in just a minute. I just need to take a quick break, and yeah, I'll be back soonish. See you in a little.
Ctfe note.
And I'm back. Sorry that took so long. I had a few things to do, but I'm back now. Speedy Beans, thank you for subscribing at Tier 1 for 11 months. That means a ton. Alright. Ranges. Let's go. Right, yep, so if a for each is encountered by the compiler, it's currently rewritten. Okay, so... Alright, yeah. For auto under range copy equals range, not range copy empty, range copy up front. Okay, yeah. Something like that. Okay, yep. Why are you learning D? Because I can, mostly? Yeah. That is, like, the main reason is because I can. It is an interesting looking language. I wanted to check it out, so I'm checking it out. Okay. Yep. Object with fills following interface is called a range. Okay, yep. It's input range. Ooh, interfaces. Empty equals false, huh? Okay. I guess that's part of the interface group, yeah. Alright. Have a look at the example on the right to inspect. Implement and usage of an input range closer. Okay, so yeah, int A is 1, B is 1, yet, enum empty is false. Front, okay, then pop front, yeah. Okay, yeah. Got it. Makes sense, okay? Yeah. Then, ooh, you can, ooh, there's drop and take, okay. Nice. That's cool. Okay. Yep, then there's filter and sum. Filtering. Yeah, made a little lambda calculus interpreter in D without knowing why. Yeah. I just like learning new languages and such. It's fun. Yeah. Okay, yep. Ranges are lazy. They won't be evaluated until requested. Okay, so yeah. Here, range from an infinite range can be, and so range from an infinite range can be taken. Nice. Yep. Values versus reference types. If range objects of value type, range will be copied. Only copy will be consumed. Okay. If range is a reference type, the range will be consumed and won't be set. Okay. Yeah, there's ref range. I didn't mean to click that, but oh well, yeah. Yeah, nice. Iota, I guess, is, what is, yeah, .iota, actually. Yeah. The iota is, is the numbers that lead up to it. Okay, got it. Alright, yeah, ref range, you can just borrow it, okay, yeah. Copyable input ranges are forward ranges, okay. Most of the ranges in the standard lib are structs, and so for each is usually non-destructive, though not guaranteed. If this guarantee is important, a specialization of an input range can be used forward ranges with a save method, okay. Yep, alright. Okay. And forward ranges can be extended to bidirectional ranges and random access ranges. Want to make a game in D, but I'm too lazy to do it. Yeah, I get that. Yeah, bidirectional range. So yeah, you can also go backwards. And alright, yeah, that goes through retro. Okay, so that goes backwards. Okay. Then random access range has a known length and each element can be directly accessed. Okay, neat. Alright, so that's like an array or such, yeah. Lazy ranges. Functions in standard range and standard algorithm provide building blocks which make use of this interface. Ranges enable the composition of complex algorithms behind an object that can be iterated with ease. Ranges enable the creation of lazy objects that only perform a calculation when it's really needed in iteration, e.g. when the next range's element is accessed. Special range algorithms will be presented later in the gems section. Okay, got it. Then we've got associative arrays, also known as hash maps. Alright, ooh, you do that by int bracket type, okay. Sure, yeah, alright. Better than what you get in C. Yeah. Alright, Ahsoka array, yeah. People always have weird names for this type of data structure, yeah, like hash maps, dictionaries, associative arrays. Ruby just calls them hashes, which is weird. Yeah. Ah! Yep. Where do you actually use the Ahsoka array? Ah, alright. Yep. Test whether a key is located. You've got in syntax. Nice. I like that. Ah. Alright, yeah, then, in returns a pointer to a value if it can be found, or a null pointer otherwise. Boy, there's nulls! Boy. Thus, existent checks and writes can be conveniently Ah! Alright, okay. That gets around the null issue. Nice. Access to a key which doesn't exist yields a range error that immediately aborts the application. For safe access, you can use get with key and default value. Okay, so there's not nulls. Yep. But yeah, null pointer just can just mean like, just false, okay. Alright. That's cool, okay. A's have the .length property, like arrays, and provide a remove to remove entries by their key. Left is an exercise to reader to explore special by key and by value ranges, okay. Nice. Yeah, then you can just do a key value here, which is like the index entry, yeah. So, you could technically think of any other type of array as an associative array to of integers to object to elements, which that's what JavaScript does, so we're not going to do that. Classes. All right. He provides support for classes and interfaces like in Java C++, okay? Any class type inherits from object implicitly. Classes in D are generally instantiated on the heap using new. There are always reference types, and unlike struct, aren't copied by value, okay? The GC will make sure the memory is freed when no references to an object exist anymore. Hooray! Inheritance. If a member function of a base class is overwritten, the keyword override must be used to indicate that, okay? This prevents unintentional overriding of functions. Nice. It's like Java's override annotation, but mandatory. But, alright, you only get single inheritance, that's fine. There's, like, mix-ins and some interfaces, yeah. That's alright, yeah. Okay. Final and abstract member function. A function can be marked final in a base class to disallow overriding it. A function can be declared as abstract to force derived classes to override it. A whole class can be declared as abstract to make sure it isn't instantiated. Yep. And super can be used to explicitly call base sealer, yeah. Alright, so for class objects, equal and not operators compare the contents of the objects. Therefore, comparing against null is invalid. The is compares for identity, okay. So there is null, but it is treated as a separate type because typing is such. And you use not is, yeah. Yeah. I personally don't like null. I think that, like, null is a fundamental violation of type system, but oh well. Okay, what else? Yep. For struct objects, all bits are compared. For other operation types, identity is the same as equality. Okay. And yeah, right? Yeah, basically like, alright, so use the colon system for extension, okay. Right. Fancy type which can be used for anything fun. Yeah. Okay, yeah. String type, yep. Okay. Ah. This is implicit and other way to specify the protection level, okay? And another way to specify protection level, okay? Yep. Alright, so... Oh! So you just have like a public, private... Alright, yeah. Okay, so public anything below is public, yeah. And like in Ruby. Nice, 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 nice. Okay. Yeah. D feels very Ruby-inspired, honestly. Like, with gems and... Or... I'm not sure what gems are, but yeah, like, just... There's some things that remind me of Ruby, and that's good, because Ruby's a pretty good language. Alright. D allows defining interfaces which are technically like class types, but whose member functions must be implemented by any class inheriting from the interface. Okay. Alright. Yeah, for example, make noise here. Must be overridden. Virtual function, yay. Must be implemented by dog because it inherits from animal. Essentially, make noise behaves like an abstract member function in a base class. Though a class may only directly inherit from one base class, it may implement any number of interfaces. Then there's non-virtual interfaces, which is just default methods. It's just default methods, okay. This pattern prevents the violation of a common execution pattern. D enables NVI by allowing final non-overridable functions, okay. Enforce specific behaviors customized by overriding other abstract oh, so you can't have a default and also? Huh. Right, I guess you can't have a default and also allow overriding it? Yeah, inheriting from interface and class, yep. Yeah, you just use commas, okay. Inheriting interface from interface, yep. Member function, yes, static member function. Ah, okay. So yeah, or no, yeah. That's, alright. Not what I'm looking for, just gonna, final member, yep. Relevant only for class interfaces, structs don't support inheritance, yep. Cannot be redefined by a subclass, okay. But, alright, I'm just gonna try this in like the experiment. Can I, void, yell, make noise? Is that, that legal? Okay. George Rotolan, thank you very much for the follow. Welcome to Uplink City. Alright, okay, that is the first patch I've come across with this. This is, you cannot override default interface methods. Okay. Fine. I don't like that, but, here we are, I guess. Yeah. Templates! D allows defining templated functions similar to C or to C++ and Java. For generics, okay. Template parameter T is defined in a set of parentheses in front of the actual function params. T is a placeholder which is replaced by the compiler when actually instantiating. Using bang, okay. Yeah, you use parentheses for it, not angle brackets. Okay, sure. Two param sets. First is compile time arguments, second is for runtime, okay. Yep, non-temp functions can accept only runtime args, yeah. One more compile time args are left unspecified when the function is called. Compiler tries to deduce them from list of runtime args. Yeah, basically just type deduction. Okay, yeah. Template properties. Function can have any number of template params which are specified during instantiation. Template params can be of any basic type, including strings and floating point numbers. Templates, unlike generics in Java, templates in D are compile time only and yield highly optimized code tailored. Not quite. To clarify, because I know what they mean here, it is not exactly what they say. Generics in Java technically don't exist at runtime either, but in a different way from D. You know, like, it being generic in D doesn't exist at runtime. In Java, the actual... yeah, it's what exists at runtime that doesn't exist is the different thing. So, like, in D, all uses of a... so in D, all uses of a template or generic are turned into canonical versions for that type at compile time. At Java, they just all turn into object. Every single one. Types inside of generics in Java don't exist at runtime. The type checking is compile time only. But for D, it's the existence of it being a template is compile time only. Interesting. Okay. Delegates. Function can also be a parameter to another function. Ooh, function pointing. Okay. So you could just do it like that, okay. Alright, so you do it with return type function. Yeah, okay. That makes sense. Nice. That's honestly a good way to do it instead of whatever the fuck Java's doing. Yeah. Here can then be called like any other normal function, yep. Yep, use the function type, which is a pointer to a global func. As soon as the member function and local function is referenced, delegates have to be used. It's a function pointer that additionally contains info about its context or enclosure, thus also called closure in other languages. Okay. Yeah. Delegate that points to a member function of the class also includes the pointer to the class object. Delegate created by a nested function includes the link to the enclosing context instead. However, the decompiler may automatically make a copy of the context on the heap if it's necessary for memory safety. Then the delegate will link to this heap area. Okay. Yeah. Then function. Yep. Do something, taking a delegate would look like this, yeah. Alright. Yeah. Delegate and function cannot be mixed, but the standard function to delegate converts a function to a delegate. Okay. Anonymous functions and lambdas. As functions can be saved as variables and passed to other functions, it is laborious to give them their own name and to define them, so you allow nameless functions and one-line lambdas. Okay. Yep, so it just... lambdas are sugar, okay. Also possible to pass in strings as template args to functional parts of D standard lib, okay. For a convenient way to define a folding, aka reducer. Nice. Cool. Alright, yeah. Sure. String functions are only possible for one or two arguments and use A as first and B as second. Okay, so it's very limited. I think that's fine, because, like, it being a string gets taken out at runtime, or at compile time. Alright, yeah. Then you're just doing, like, this is like that operation thing from earlier, but this time it is, with lambdas. Yay. Okay. Ha. Alright. Exceptions. This guide is only about user exceptions. System errors are usually fatal and should never be caught. Okay. Common case for exceptions is to validate potentially invalid user input. Once an exception is thrown, the stack will be unwound until the first matching exception handler is found. Alright. Possible to have multiple catch blocks and a finally that's executed regardless. Exceptions thrown with throw. Alright, pretty basic, yeah. Sounds good. Remember, scope guard is usually better solution to try finally. Scope guard, what are you? Oh, that's a these gems thing. Okay, so yeah, we'll get to that in a bit. Yeah, let me just close these out there. Yeah, we'll check out the scope guard later, but yeah. One can easily inherit from exception and create custom exceptions. Yep, pretty basic. Enter a safe world with no throw. Okay. Just checking, is this the standard syntax to have a line break before the curly bracket? Because I don't like that. Don't like how it looks. Yeah. Can ensure a function can't cause catastrophic side effects. Such functions can be annotated with no throw. Compiler statically forbids throwing exceptions in no throws. Okay. Alright. Please note the compiler is able to infer attributes or templated code automatically. It's important to avoid assert in the soon-to-be-introduced contract programming for user input, as certain contracts are removed when compiled in release mode. They're just testing. For convenience, standard exception provides enforce that can be used like assert but throws exceptions instead of an assert error. Okay, yeah. I like the error versus exception split. That's good. It is in the opposite direction of Java's, where errors are a user input thing and exceptions are fatal, but oh well. There's more in standard exception, yet where an error might not be fatal, one can opt in to collect it. Okay, so collect exception. Then, yeah, okay. Test whether an exception is thrown in test, use assert thrown. Okay. Cool. Then further reading, okay. Finish the basics, you can move on to some advanced sections. Then there's other things, so like, there's, yeah. Alright, some other resources, tutorials, wiki, FAQ, Phobos, language reference, d.announce, okay. That's just forum, okay. Yep, forum, dub repository, compiler, sources, style. What's the style guide? Alright, so camel case. Alright, all lowercase modules. Yep. Pascal cased. Alright. Anonymous templates, okay, yeah. Functions, yeah. Alright, camel cased. Enum members, be camel cased. Huh, alright. Yep, acronyms, user type aliases, okay. Declaration style, yep. Left associative, yeah. Since decks are left associative, left justify, okay. Operator overload, right. Hungarian notation variable type. What the fuck is Hungarian notation? Yeah, let me zoom this in for y'all, by the way. Yeah. Property syntax, okay, yeah, UCFS. Test requirements for Phobos. Traces should be... at least... This is at least for Phobos and D source code, but yeah. Small section on white space top contains its only formatting guidelines, so yeah. This guide does not try to recommend or require code conform, but they use new line braces. Blah. Wah. Don't like that. Just nitpick. Okay. New lines for else if. And, that is not what I enjoy. Oh well. UFCS. This is a cool thing that folks have told me about. Let's go. Yeah. UFCS is a key feature of D and enables code reusability and scalability through well-defined encapsulation. That is uniform function call syntax. So UFCS allows any call to a free function fun A to be written as a member function call a.fun. That's cool. A.fun is seen by the compiler and tech doesn't have a member function called fun. It tries to find a global function whose first parameter matches that of A. Yeah, that's why you'll see things like .iota or such, yeah. That is cool. I like that. It means that you can basically pick what you want. So yeah, a.bar.foo, yeah. Basically it lets you put things in left to right syntax instead of right to left, like that. Okay, yeah. Not necessary to use parens for functions without arguments, which is neat because you can then treat functions like properties, but yeah. Especially important when dealing with ranges where several algorithms can be combined to perform complex ops. Yep. This does feel like it could be, like... does feel like it could be a bit foot-gunny at points, but yeah. Alright. Especially important when dealing with ranges where several algorithms can be combined. Yep. Yeah, you can do, like, stuff like that. I think not having the parens in makes it look a bit better, but yeah. Ah. Alright. And... next. Scope guards! What are you? Alright, scope exit will... Alright, scope guards allow executing statements at certain conditions if the current block is left. Scope exit will always call. Scope success will call when no exceptions have been thrown, and scope failure donates statement. No, statements will be called when an exception has been thrown. Okay. You know, we haven't gone over enums, have we? Have we not gone over enums? Oh well. I'm guessing they're pretty standard enum-y things, but yeah. The scope feature effectively replaces the RAII idiom in C++, which often leads to special scope guard objects. What the fuck is C++ RAII? What is that? The resource acquisition is initialization, okay, which binds the life cycle of a resource that must be acquired before use to the lifetime of an object. Okay, got it. Yeah, this is basically similar, okay. Yeah. Ah, okay. So you just do something like that, okay? Neat. And I'm guessing you can, like, put the scope stuff in brackets or whatever, but yeah. That's neat. It's basically just like an on-close or such. Or drop or whatever, yeah. Scope guards are called in reverse order, they're defined. Yeah, alright. Yeah, okay. You could do some neat stuff with that, okay. Range algorithms. Standard module, standard range, and standard algorithm provide a multitude of great functions that can be composed to express complex operations in a still readable way, based on ranges as building blocks. Great thing with these algorithms is that you just have to define your own range and you'll be directly able to profit from what's already in standard lib. Yay! Yeah, you've got like your filter, your map, your each. Yeah. Remains for each is a range crunching function, but yeah, fun, yeah. And I'm guessing they just get like, yeah. They get optimized down or such, but yeah. Yep, then you've got take, limit to n elements, okay. Iterates over two ranges in parallel. Yeah. Yep, zip, iterates over two ranges in parallel, returning a tuple from both ranges, okay. Takes a... Alright, generate creates a range which in turn calls it for each iteration. Alright. Alright. Yeah, that's... Alright, yeah, that's neat. Alright, returns a range that repeats a given input forever, okay, yeah. Documentation is awaiting your visit, fun. Yeah. Yeah, lots of cool things. We've got your, like, join, yeah. Got your like joins and such. But yeah. Yeah. This tour will give you an overview of this powerful expressive system's programming language which compiles directly to efficient native code. Yep. Yeah, then that will find yeah, so predicate is yeah, so basically can find a backend, okay. Then splitter, yeah, with predicate, okay. Ooh, you can use that as compile time, nice, okay. Then filter. Yep. Alright. Yeah, the bangs for templating are neat. Okay, yeah. Then you map, A count, yeah. Like just this all being like compile time is very nice. then you've got, like, array, then sort, unique ones only. Yep. All in one row, same car count. Alright, chunk by, okay, yeah. Generating ranges of range that are chunked by the length, okay. Alright, then. Those elements will be joined on one line. Just the words. Printer joins, but lazily now the lines with line feed, okay. Pipe to change out. Let's see what this. Yep. Okay. Interesting, alright. Yeah. Alright, that is just like sorting out like the word lengths and stuff. Okay. Unit testing! Let's see what you got. Tests are an excellent way to ensure stable bug-free applications, serve as an interactive documentation, and allow modification of code without fear of breaking functionality. D provides a convenient and native syntax for unit test blocks as part of D. Nice. Anywhere in a D module, unit test blocks can be used to test functionality. Neat, yep. Allows straightforward test-driven development on demand. That's cool. It's just like being able to put the unit tests right next to like the things it's testing, I think is pretty neat. I think that's good. Then you can run execute unit test blocks, yep. Arbitrary code compiled in and run when command line flag unit tests passed to DMD. Dub also features compiling and running unit tests through dub test, okay. Then you've got, yep, your typical assert, which basically just you want it to return something true. Test function of given function. Unit test typically located near definition of function, which might be at top level source or even within class structs, okay. Powerful weapon to ensure bulletproof applications. Yeah, code coverage, okay. Yep. Ratio of executed versus existing code, yep. The MD compiler makes generating code coverage reports easy by adding -cov, okay. Every module.lst file which contains detailed statistics will be generated. That's neat. As the compiler is able to infer attributes or templated code automatically, it's a common pattern to add annotated unit tests to ensure such attributes, yeah. Safe, no GC and such, yeah, no throw, pure, okay, yeah. Alright. String mixins. The Mixin Expression takes an arbitrary string and compiles it and generates instructions accordingly. It's pure compile time and can only work on strings available during compilation. Yeah, a comparison with the evil JavaScript eval would be highly unfair. Yeah, So yeah. Mixin also works with strings constructed dynamically as long as the available info doesn't depend on runtime values. Okay, that's cool. Alright, yep. Mixin together with compile time function eval allows writing impressive libraries like pegged, which generates a grammar parser from a grammar defined as a string in the source code. Ooh! Tasty! That's cool. Alright. I might give that a look sometime. Neat. Okay. And yep, also works with string, yep. Alright, so yeah. Stuff like this. LHS, tilde op, tilde LHS, yep, with calculate. Yep, you've got your compile time, the runtime args, okay. Yeah. You just put, yeah, you have like a Mixin right ln here, yep. You wouldn't usually do something like that, you would want to do something there, but yeah. Then, yeah, then you've got like, okay, yeah. Then 5 plus 12 equals, then calculate, yeah. Yeah, that is cool. So that'll be 17, 2, 4, 20, yeah. Woo! Yeah, that's neat. I like these mixins. Alright, then Ctfe Mechanism, which allows the compiler to execute functions at compile time. There's no special set of the D language necessary to use this feature. Whenever a function just depends on compile time known values, the D compiler might decide to interpret it during compilation. Nice. Yep, so, like, this will be calculated at compile time. Check the machine code won't contain a function call. Ooh. Can you check the machine code? Ooh. Nice! That's cool. Okay, so yeah. Yeah. Keywords like static, immutable, or enum instruct the compiler to use Ctfe whenever possible. Okay. Great thing about this technique is that functions don't need to be rewritten to use it, and the same code can perfectly be shared. Awesome. Yeah, same function as above, but this time was just called during classical runtime. Yeah. Yep, one prominent example is the standard regex library. Provides regex, ctregex, which uses string mixins in Ctfe to generate a highly optimized regular expression automaton that's generated during compilation. Then it's reused for the runtime version regex that allows regular expressions only available at runtime to be compiled. That is cool. That's really cool. Like, that is honestly one of the neatest things about this, but yeah. Not all languages features are available during Ctfe, but supported feature sets increase with every release. But yeah. Yeah. Yeah, like, this is like just part of like the Squirt stuff, and yeah. Very cool. Yeah. Alright. And functional programming. D puts an emphasis on functional programming and provides first-class support for development in a functional style. In D, a function can be declared as pure, which implies that given the same input parameters, same output is always generated. Pure functions cannot access or change an immutable global state, and are thus just allowed to call other functions which are pure themselves. No side effects, yeah. Can't call impure stuff, you just annotate as pure, yeah. Variant of add is called a strongly pure function because it returns a result dependent only on its input params without modifying them. D also allows the definition of weakly pure functions which might have mutable params. Okay. And that's basically just, you pass a referent in. Okay. Still considered pure and can't access or change any mutable global state. Just passed in mutable parameters that might be altered, okay. Due to the constraints imposed by pure functions are ideal for multi-threading environments to prevent data races by design. Additionally, pure functions can be cached easily and allow a range of compiler optimizations. Neat. The attribute pure is automatically inferred by the compiler for templated functions and auto functions where applicable. Also true for safe, no throw, no GC, okay, yeah. Very nice. Ah. Yeah. I think stuff, yeah, auto stuff is very good. Oh boy, they've got big ints. Wee. Alright, so yeah, this basically just like, alright, this benchmarking, fun. Yeah, basically that just lets it cache. Nice. Yeah. That is neat. Okay, contract programming. Contract programming indeed includes a set of language constructs that allow increasing the code quality by implementing sanity checks that make sure the codebase behaves as intended. Contracts are compiled and executed when software is built for testing or debugging. In release builds, they're completely omitted by the compiler, therefore they shouldn't be used to validate user input or as an alternative using exceptions. Right. Assert is contract programming. Checks when a certain condition is met and aborts with assertion error otherwise. Yeah, that's a contract. Function contracts. In and out allow contracts to be formalized for input params and the return values of functions. Okay. Yeah, that like, well, yeah, so you can have basically tests on the input and output of functions to make sure they're never being passed something wrong, make sure they're never returning something wrong. That's cool. Okay. And content in the in block could also be expressed within function body, but the intent is much clearer this way. In the out block, the return value can be captured without result and verified accordingly. Yeah. Yeah, that's good for like testing, and then it can be optimized out and such. Yeah. Invariant is a special member function of struct and class types that allows sanity checking an object's state during its whole lifetime. Called after the constructor's been run and before the destructor's called. It's called before entering a member function, and invariant's called after exiting a member function. Alright. So I guess that's just a built-in one? Yeah, I don't see it being used. Oh, there it is, yeah. Yeah, invariant is just called all the time, okay, yeah. Or anytime you just put stuff in there, yeah. Validating user input. As all contracts will be removed from the release build, input should not be checked using contracts. Moreover, asserts can be still used in no-thread functions because they throw fatal errors, which are not catchable exceptions. Runtime analog to assert is enforce, which will throw catchable exceptions. Okay. Subtyping. Structs can't inherit from other structs, but those poor structs D provides another great means to extend their functionality. Subtyping, okay. Yep. Yeah, struct type can define one of its members as alias this. Okay, any function or operation on safe int that can't be handled by the type itself will be forwarded to the alias this member. Okay. And the outside safe int then looks like a normal integer. Okay, yeah. This allows extending other types with new functionality but with zero overhead in terms of memory or runtime. Compiler makes sure to do the right thing when accessing the alias this member. Nice. That is cool. Alright. Yeah. I think that is a pretty good way to do like subtyping for structs. Ah. Alright. Attributes. What are you? Alright, that's... Alias reminds me of Rust's deref, yeah. A bit. Yeah. Functions can be yeah. It looks awesome, yeah. It does look pretty cool. Functions can be attributed in various ways. Let's look at two built-in attributes as well as user-defined ones, okay. They're also built-in, safe, system, and trusted, mentioned earlier, yeah. Alright, so at property, yeah. Okay, yeah. Functions that can be syntactically treated as if they were fields or variables. Properties can be read from or written to. A property is read by calling a method or function with no args. Properties written by calling a method or function with its argument being the value it's set to. Okay. Yeah. Looks like a normal member to the outside world. Okay, neat. That is cool. Yeah, that just kind of looks like that. Okay. Yeah, it looks like a normal property, but it can do other stuff. So no GC when it can... Yeah, it encounters a function marked as no GC. It'll make no memory make sure no memory allocs are done within the context of that function. No GC is allowed to call other no GCs. Okay. Neat. Alright, then... User-defined attributes. Any function or type in D can be attributed with user-defined types. Yeah, you've got your... Yep. Stuff like that, okay. So, okay, yeah. You can with it. Yeah, you can attribute with any struct, okay? Yeah. Any built-in... Yeah, any type built-in or user-defined can be attributed to functions. Function foo in this example will have the attributes hello, type string, and bar type bar with value 10. To get the attributes of a function or type, use the built-in compiler traits under traits, get attribute foo, which returns an aliasing. Okay. UDAs allow generic code to be enhanced by giving user-defined types another dimension that helps compile time generators to adapt to that specific type. We'll be looking at traits in a bit, I think. But yeah. Hey, yeah. UDAs look neat. Yeah, like being able to just use almost anything as an annotation, yeah. Alright. D allows overriding operators like plus, minus, or call for classes and structs. We'll have a closer look at the two special operator overloads, op dispatch and op apply. Hooray, overload, yeah, hooray, operator overloading. Alright. Op dispatch can be defined as a member function of either struct or class types. Any unknown member function called to that type is passed to op dispatch. Passing the unknown member function's name as a string template parameter. Op dispatch is a catch-all member function, allows another level of generic programming completely at compile time. Nice. Alright. yeah. So something like this, okay. Yeah. It is interesting that you can override the call operator. That's fun. Yep. So yeah. Yep, a property op dispatch, yep. Host name. Then you can have like var there, okay, yeah. Right. Type that can be filled with op dispatch with any number of members like JavaScript's var, I see, yeah. Okay. Yeah. Very cool. Basically just lets you do whatever, yeah. Yeah. Yep. Yeah, then it would need to exist already and such, but yeah. Right, so op apply, an alternative way to implementing a for each traversal instead of defining a user-defined range is to implement an op apply to member function. Iterating with for each over such a type will call op apply with a special delegate as a parameter, okay. Alright. This compile transforms the for each body to a special delegate that's passed the object, or to the object. One and only parameter will contain the current iteration's value. Okay, magic int return value must be interpreted, and if it's not 0, iteration must be stopped. Okay. So yeah, like... let's see, so yeah. Yeah, it's like if LHS, yeah. And RHS, yep. So if LHS and LHS op apply, because that will return non-zero, yeah. And that'll stop, then... DG this, which is, basically it's stuff in there, yeah. Yeah, delegate, run, then return 1, then, return 1 there as well, yeah. Okay. Yeah, op dispatch, yeah, that stuff, okay, yeah. Yeah. I'm about to take another break, so I'll do that in just a minute. Right, what's up next real quick? Documentation, ooh. Doc strings. D tries to integrate important parts of modern software engineering directly into the language. Besides contract programming and unit testing, D allows documentation to be natively generated from your source code, using doc comments, nice. Standard schema for documenting types and functions, command dmd-d generates HTML docs based on the source files. While Phobos library doc has been generated with ddoc, nice. Following comment styles considered by ddoc, so triple slashes before type or function, multi-line with 2 pluses, and multi-line with 2 stars. Okay, neat. Yeah, great! I'm gonna look, alright, yeah, not a super long one, I can do this before I break, but yeah. Allow the accepted input type to be explicitly defined. Split into words can operate on any arbitrary string type. Yep. Yeah, basically you just use an if there, yeah. This applies to template parameters as well, and MyWrapper can ensure passed-in symbol is callable. Yep, is callable. Common prefix, yep. Good, yeah, it's a trait, so yeah. Returns common prefix of 2 ranges will be analyzed. So yeah, you've got all these checks. Function only callable and thus compiles if R1 is savable, R2 is if back with food, macaroni, bacon, pizza, by the not sure heard you asking up, yeah. Ooh, hope you enjoy the food, but yeah. Yeah, R2 is iterable. Yeah, pred is callable with elements of types 1 and 2. And R isn't a narrow string, okay, yeah. Yeah, for simplicity, otherwise decoding might be needed, okay, yeah. Specialization. Many APIs aim to be general purpose. We want to avoid any extra runtime costs for convenience. Power of introspection is Ctfe, possible to specialize the method at compile time to achieve best performance. Yeah, very cool. Yeah, basically a static if-else. Neat. That is cool. Common prefix difference between random access ranges and linear iteral, because possible to jump between positions and speed up, and some other Ctfe magic, yay. Alright, so there's standard traits, okay. And keywords, yep. So file, line, module, function, pretty function, cool, yeah. CLI evaluation doesn't even need time, Ctfe can be used. Nice. That is neat. But yeah, I am gonna be right back. I will see y'all in just a minute. And I'm back. Okay. Yeah, like just, there is a bunch of very cool, things that are just part of D, like just this special keyword stuff with, and the Ctfe traits and such. I think Ctfe is just one of the coolest things that D has. Yeah. 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 Ah. Okay. Yeah, I didn't get to check what this is before break, but yeah, so got primitives, ND front, pop front, is input range, is forward range, is random access range, has slicing as length, and right lang narrow is narrow string, binary fun. It returns common prefixes to ranges without without the auto decode special case, okay? Predicate for commonality comparison, then forward range and input range, but yeah. Yeah. Basically just generics with type constraints, which is neat. I think, yeah. I think having something to, like, note that, like, yeah, I'm not sure of, like, better ways to do that. Like, Java's kind of works, but it's just a mess, but yeah. Yeah. Yeah, like, yeah, because Java's pretty much only lets you have, like, one constraint, which is type, but yeah. Right. Template metaprogramming, what are you? Yeah. If you ever got in touch with template metaprogramming in C++, you'll believe what tools D offers to make your life easier. Template metaprogramming is a technique that enables decision-making depending on template type properties, and thus allows generic types to be made even more flexible based on the type they're going to be instantiated with. Yeah. We've got normal and, yeah, so we've got static if. Conditionally compiles a code block based on a condition that can be evaluated at compile time. Neat! Okay. Yeah, then we've got, is a generic helper that evaluates conditions at compile time, so yeah. Neat, okay. Which is different from is as a keyword for, like, is null, yeah, for identity checking. Braces are omitted if condition is true, no new scope is created, yep. Brace and brace explicitly create a new block, okay, yeah. Template metaprogramming, yeah. Static if can be used anywhere in the code of functions, global scope, or within type defs. Then you got Mixin Templates, and where you see boilerplate, Mixin Template is your friend. Mixin Template might contain any number of complex expressions that are inserted at the instantiation point. Say goodbye to the preprocessor if you're coming from C. Nice. Mixin Template might contain... Oh no, I read that, yeah. Template might be defined with any number of constraints that enforce what properties a type must have. So yeah. Yeah, basically, you can, like, just declare, works if is t int, yep. Or, yeah, if it can convert to int. Constraints can be combined in Boolean expression and might even contain function calls that can be evaluated at compile time. So, its random access range checks whether a type is a range that supports the slicing operator, okay. In depth is empty. Wee. Okay, but there are, like, basics and advanced references and such, but yeah. Vector that just works for numbers, insert floating points, yeah. Alright. Yep. So, is T real basically just works for, yeah, is what you want to use for all numbers, yeah. Generator for getter and setter because we hate boilerplate. Yeah. Very cool, but yeah. Ah. Yep. Use Mixin to construct function names. Yeah, get and sets. Nice. I think that is cool. Yeah, I do think there are a couple things that I would prefer with this, because, like, this is still, like, if you have to do this for every type, then still, that's some boilerplate. Yeah. Not nearly as bad boilerplate, but still. Dot functions only available for floating points type, floating point types, yep. Static if, yeah. Then you've got your main void, yep. vector 3 double. Doesn't work because template constraint. Yep. So vector 3 is legal. Yep. Then you've got dot products. All right. Can't dot product because we only enabled it for floats. Then we've got your generated getters setters. Nice. Bitmanip. An excellent example of D's ability to generate code at compile time with mixins is Bitmanip. Alright. D offers the following operators for Bitmanip: Bitwise and Bitwise or Bitwise negative, Bitwise signed left shift, Bitwise signed right shift. And Bitwise unsigned right shift. Alright. Yeah, neat. So yeah, common example is to read the value of a bit. D provides for bitop.bt from contests, but let's start with some verbose code. I'm still getting tripped up by, like, using enums there. Does this talk about enums? Sure, is there a way to search? Yeah, enum. Yeah, is there a way to search, like, the tour? Indeed, enum just means compile time. Okay, got it. Wait, wait, there's... Yeah, normally enums also exist, but they're considered compile time stuff too, I know. I see. Okay, sure, yeah. Alright. Nice. I can respect that. Alright, but yeah. So, just means compile time. Okay, yeah. Yeah, just assume compile time with enum. Alright, yeah. Generally, so yeah, we've got enum, like, pause A is 1, enum mask A is 1, left, yeah, is 1, left shift, pause A, yeah. Yeah, then you can get field A, you can return under data and mask A. Nice. Yeah. Generalization is to test for blocks that are longer than 1. Hence, a special read mask with length of the block is needed, and the data block is shifted accordingly before applying the mask. Yeah. Got pause A, len A, mask A, yeah. Post Java equivalent is public sec, final improved is where it gets inlined. Yeah, that's what I, yeah, or like const in other in languages other than D, where D uses const as like a different thing. So yeah, basically enum gets inlined. Yeah, which like most enums do. Ah, weird hiccups. Adderall is not being nice to me today. Yeah, setting such a block can equivalently be defined by negating the mask and thus only allowing writes within the specified blocks. Yeah. Now, here's a question. Can you do bitwise assignment operators? Because that would be cool. Enum gets inline, but can also be used by templates since it's compile time. Good thing to know, yeah. Yeah, enums are dealt with at compile time, okay, yeah. Yeah, that gets 1 shifted by 3 minus 1, okay, so yeah. Yep. Then shift right, signed by 1, and with mask A, yeah. Setting such a block can equivalently be defined by negating the mask and thus only allowing writes within the specified block. Okay, yep. Yeah. Bit shifts are neat. Yeah. Yep. bit flags are cool, and it's good that they've got some good tools for them. But yeah. Then you've got standard Bitmanip. Okay, yeah. So it just does that for you. Yeah. Most cases don't want to copy paste code like this, especially since it's very error prone and hard to maintain. So you've got standard Bitmanip to write maintainable, easy to read Bitmanips with standard. What the? God, hiccups. Yeah. The standard Bitmanip and the power of Mixins without sacrificing performance. Hooray, compile time! Yeah, exercise section. Yep. Bit vector is defined but still just uses X bits and it's nearly distinguishable from a regular struct. Yeah. More helpers that are very helpful for applications that require low memory usage. Okay. Since the compiler adds padding to vars whose size is less than the current OS memory layout, e.g. bool byte car, recommended that you start with fields with high alignments. Okay. Yeah, like, let's look at this. So, yeah. Yeah, standard Bitmanip and bit fields, yeah. Creates a private field with the following proxies. Okay, so yeah, mixin bit fields, bang. So uint x2, int y3, uint z, and full flag 1. Okay. So yeah, then we've got standard IO, right format line and right line. So yeah, got a bit vector vec. Alright, so vec x is 2, vec z is vec x minus 1. Yep, then you can just do all that. Yep. Vec x, y, and z. Only 8-bit minus 1 byte. Only 8 bits to 1 byte are used. Or yeah, this whole bit vector is ultimately just stored in a single byte. Yeah, that'll be size of 1, yeah. Then you've got a vector with int x, y, and z, so that's 4 bytes per variable. So yeah. Then a bad vector due to padding 4 bytes are used for each field. That's cool. Bit flags are great. Yeah, this bit fields, yeah, that's uint, so that's 2 bits, 3 bits, 2 bits, and 1 bit. Yeah, just hooray for byte padding. Basically, if you're using more than, basically, if you're using more than one boolean, just use bit fields, but yeah. Unicode in D, okay. Unicode's a global standard for representing text in computers. D fully supports Unicode in both the language and the standard lib. Computers at the lowest level have no notion of what text is and they only deal with numbers. Yep, computer code needs a way to take text data and transform it into, from a binary representation. Method of transformation is called an encoding scheme, and Unicode is one such scheme. Yep. You can run the code to see like the underlying values and such, but yeah. Unicode's unique in it that its design allows it to represent all the languages of the world using the same encoding scheme. Yep. Mostly, but yeah. For more information, see Wikipedia article on Unicode and in-depth section. Unicode solved most of these problems and is supported by just about every modern machine. Yep. In D, all strings are Unicode, whereas strings and languages in C and C++ are just byte arrays. Yeah. Must save points. Aw, you got an idea for him? Yeah, string, W string, and D string are UTF-8, UTF-16, and UTF-32 encoded strings, respectively. Then you've got character, W character, and D character. Yeah. Yeah, word car and D car. Yeah, double car, yeah. And it is an error to store non-Unicode data in the D string types. Expect your program to fail in different ways if your string is improperly encoded. If you want to store raw bytes, just use a U-byte array or car pointer, yeah. For C or C++ behavior, but yeah. Alright. Then, alright, we've got range algorithms, which is, which is up there, yeah. Yeah, there's some caveats to keep in mind when working with Unicode and D. When iterating over string using range functions, each element of strings and W strings is converted into a UTF-32 code point as each item. This practice known as auto decoding means that, it will always just, range algorithms will always treat it as a double car. We both know how predictable I am, you know which redeem I have my eyes on. Oh. This behavior has a lot of implications. The main one that confuses most people is that has length string equals false, because in terms of the range API, string's length returns the number of elements in the string rather than the number of elements the range function will iterate over. Yeah, strings are a mess and a nightmare, and falsehoods programmers believe about text is a big list. From the example, you can see why those two things might not always be equal. As such, range algorithms act as if strings don't have length information, okay. Yeah. Yep. Check yep. So they've got details on auto decoding and what it means for your program for over here. So yeah. So yeah, I can take a look at this sometime, but yeah. 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 Arrays only specify, yep. Use UFCS and such, yeah. Yeah. Strings are weird and a mess, yeah. They're not library types, they're just aliases to array types, yeah. A lot of stuff. Thread local! Alright, it is time for multi-threading. The storage class static allows declaring objects which are initialized only once, okay. If the same line is executed a second time, the initialization will be omitted. Every thread will get its own static object, the thread local storage, and won't be able to read or modify another thread's static object, although the variable name stays the same. Thus, static allows declaring an object that holds state that is global for the current thread. Neat! This is different to C, C++, and Java, where static means global to the application, entailing synchronization issues in multi-threaded apps. The value assigned to a static var must be evaluable at compile time. Just treat it like it's being inlined. Mustn't have runtime dependencies. If it's possible to initialize static variables at runtime using a static... Yeah. Or it is possible to initialize static vars at runtime using a static this, one-time constructor, structs, class, and classes and modules. Okay. Yeah. Yeah, B is just initialized once. When run from different threads, each B will have its, we'll see its own B without interference from other threads. Okay. Moreover, for declaration of a classic global var that every thread can see and modify using the storage class under G shared, which is equivalent to C static. Its ugly name is a friendly reminder to not use it. Yeah. Yeah, that is dangerous to modify, but yeah. Yeah. Okay, yeah. Very cool things. Ah. If I run this, yep, that'll only print 5 times. Oh, 10, yeah, because it... Alright, yeah. Yeah. I misread that a bit, whoops. Yeah. Yay! Multiple thread IDs and such, but yeah. It's good to have, like, just... Yeah, you've got, like, your thread spawn, the thread ID and such, yeah. Message passing! Instead of dealing with threads and then doing sync yourself, D allows you to use message passing to take advantage of multiple cores. Threads communicate with messages, which are arbitrary values to distribute work and sync themselves, okay. They don't share data by design, which avoids common problems of multi-threading, okay. All these passing functions can be found in standard concurrency. Spawn creates a new thread based on a user-defined function, so yeah. Yeah, you just like function pointer and such, yeah. This TID is a standard concurrency built-in and references the current thread which is needed for message passing. Spawn takes the function as first parameter and additional parameters to that function as arguments. Okay. Yep. You'll have something like this, so you can pass your thread ID in there. Yeah. Yep. Yeah, then you can receive... But yeah. Alright, you get send and receive. Okay. Receive function is like a switch case and dispatches the values it receives from other threads to the past delegates, depending on the received values types. Okay, so yeah, you call send and receive to send and stuff like that. Okay, yeah. You can send a message to a specific thread using the send function and the target thread's ID. Nice. Receive only can be used to ensure that only a specified type is received. Okay. Yeah, that's generics. Receive family functions block until something's been sent to the thread's mailbox. Okay, yeah. Yeah, basically it just like waits until it's got something to do. Yeah, over here we can see some of this stuff. So got a number message which contains a number and has this inside. Yeah, it has a this for initialization. Then message used as, or yeah, then you've got a cancel message, a cancel acknowledgement, thread worker main function, which it gets its parent ID passed as an argument. Okay. Yeah. Yeah, it just this lets you send back to the parent. Okay. Yeah. Cancel this. Oh wait. All right. Yeah, that's why you can't have like a Bitwise negate resign, because tilde equals is already for append. Yeah, while not canceled, then you can just receive. Yep. Okay. Yeah. Then you can just, it does the send, the cancel act and such. Yeah. Odd threads get number, even threads a string. Fun. Yeah. Alright. Yeah, it just does like, iterates through. Alright, yep. And all threads get canceled at the end, and wait till all threads have acknowledged their stop request. Right, yay. That's cool. It is, yeah. It is very nice that you have, it has like that, yeah, a thing for like acknowledgement and confirm close and such. But yeah. Sync and sharing, okay. Preferred way to do multi-threading is to rely on immutable data and synchronized threads using message passing. However, the language has built-in support for synchronization primitives, as well as type system support with shared to mark objects that are accessed from multiple threads. Use the shared type ID to mark variables that are shared among different threads. This is a shared int pointer. Okay, yep. Yep. Yeah, you can't assign that because they're different types. Send only allows sending either immutable or shared data and copying the message to be sent. Shared is transitive, so all members of a class or structure shared. Static vars aren't shared because they're using thread local storage, and each thread gets its own var. Sync blocks are used to tell the compiler to create a critical section that can only be entered by one thread at a time. Okay. Within class member functions, these blocks might be limited to different member object mutexes. Okay, yep. With synchronized to reduce contention, the compiler inserts critical sections automatically. A whole class can be marked as synchronized as well, in which case the compiler makes sure one thread accesses a concrete instance at a time. Got atomic ops can be, yep, atomic op helper. Oh boy, atomics. Yeah, then over here you've got queue that can be used safely among different threads. All access to an instant automatically locks thanks to synchronized. Nice. Yay, automatic mutexes. That's good. Must be private in sync classes, otherwise D complains. Yep. Makes sense. Alright, yeah, then you can push a value. Yep, return key and if queue empty. Yeah, that'll pop. Yeah. Alright, yep. I think, yeah, there's a good reason that it will, like, complain here, because, like, you want to make sure it's only used by one at a time. Alright, so standard array empty, yep. Okay. Safely print messages independent of number of concurrent threads. Variadic parameters are used for args. As args might be O.N, okay. Yay, var args! Yeah. Var args are cool, I think. Yeah. Okay. Yeah, it's got a safe print. One thing, I'm guessing that D has forward referencing, but yeah. Yep, then a thread producer, okay, yep. Brings its shared safe queue with it, then shared queue counter. This does 1 to 10, yep. then it can print. Yeah, push, then it does a safe print. Then atomic op. Alright, yep, Q adds Q counter. For consumer, yep. Yep. Alright, shared safe queue in Q, shared in pointer Q counter, yep. Popped is both. While popped isn't 10. Pop from Q if it's int dot if it's initial value, continue. Safely fetch current value of Q counter using atomic load. Different pop, alright. Another atomic load, and then you send a true back, okay. Yep, then it's got a safe queue int shared, and shared int counter 0. And it can then it spawns, pointing to thread producer, sends in the queue and points to counter. Then you've got a consumer which spawns and such, then receive only bool, and then assert stop. I'm gonna be right back, just a minute. Gotta check on something. Yeah, I'll be right back. See you in a second. And I'm back again. Sorry about that. Yeah, good night, Lem. Gotta go try to sleep because work tomorrow. Oh, good luck with work, Jasper. See you later. Yeah. I gotta admit, my mind doesn't really work well with parallelism and such, so I am hoping that I get this stuff in that I can go back to it later, but yeah. It does seem like concurrency and multi-threading are not that bad with P, which is good. Alright, standard parallelism implements high-level primitives for convenient concurrent programming. Okay. Parallel allows to automatically distribute a 4H's body to different threads. Ooh! That's cool. Uses the op-apply operator internally. Yep. Global parallel is the shortcut to task pool parallel, which is a task pool that uses the total number of CPUs. Yeah, -1 working threads. Okay. Creating your own instance allows you to control the degree of parallelism. Yeah. All right. Yeah. Whereas the body of a parallel iteration must make sure that it doesn't modify items that another working unit might have access to. Okay. Optional working unit size specifies the number of elements processed per worker thread. Alright. And then you've got iteration reduced, known from other functional contexts as accumulate or fold L. Yep, calls a function fun. For each element X where ACK is the previous result. Okay. Yeah. Alright. Task pool reduced is the parallel analog to reduce, okay. Yeah, find the sum of a range in parallel using the first element of each work unit as the seed. Yeah. Makes sense. Then, task pool reduce splits the range into sub-ranges that are reduced in parallel. Once these results have been calculated, the results are reduced themselves, okay. Task is a wrapper for a function that might take longer or should be executed in its own working thread. It can either be in queued or in a task pool, yep. Yeah, you just put task bang before it, okay. Then you can put that in, nice. Or directly be executed in its own new thread, yeah. Yep, execute a new thread. To get a task's result called yield force on it, it will block until the result's available, okay. And yeah, so let's look at this. Yeah, we've got like string task. Yeah, so we've got a function here. That's the task. Import core thread duration and thread. Okay, so yeah, then it's just like a thread sleep. Then return hello world. Okay. We've got a task pool with 2 threads. We've got my task pool and yep, and stopping the task pool is important, so on scope exit, we stop it. Yeah. Alright, then start a long-running task. Yep, start long-running task. This one up there. And do some other stuff in the meantime. So yeah, we can put it in the task pool. Then, while we're doing that, we can also do, some parallel calculations. Just square all that, then we can write that right out, and that's still going in the background. Then we've got then we've got a map function, reduce to calculate the sum of all squares in parallel. Yep. So we're calling a reduce. Just go for all that, okay? Yeah. Yeah. And yep. Then we get our result we sent to the background earlier up there, okay, yeah. Yeah, this should... I accidentally put that there, whoops. Oh, no, it's because... I don't like how you can drag things around like that. Yeah, this is a pre-cached answer, but yeah. Ah. Yeah, just like... Yeah. It sums squares 1 to 100, it does the squares, yeah, for, numbers 1 through 9. Yeah. Then we've got fibers, way to implement concurrency in a cooperative fashion. All right, finding core thread. Okay. Basic idea is that when a fiber has nothing to do or waits for more input, it actively gives away its possibility to execute instructions by calling yield. The parent context gains control again, but the fiber's state, all variables on the stack are saved. Okay. Fiber can then be resumed and will continue at the instruction right after it called. Fiber yield magic? Yes. Yeah. Alright. Or right after it called fiber yield, yeah. That's cool, so yeah. Okay. Yeah. This feature can be used to implement concurrency where multiple fibers cooperatively share a single core. The advantage of fibers compared to threads is that the resource usage is lower because no context switching is involved. Very good. Yeah, usage is seen in the vibe.d framework, which, what is that? Oh, it's a REST and web app framework. Okay, yeah. I'll give it a look at some point. Yep. Implements non-blocking I/O in terms of fibers, leading to much cleaner code. Neat. Let's see how these work over here, yeah. Iterates over, range and applies the function func to each element x and returns it in result. Yep. Fiber yields after each application, so yeah. Yeah, we've got func, then R and T, we've got an R range and ref T result. Yeah. Don't care what it is, but while the range is not empty and we're popping front, we'll call, func on the front, and then yield. We've got ints for square result and cube result. We're going to use fibered ranges, one of them for squaring, and numbers 1 to 10, and one of them for cubing numbers 1 to 8. And then they will just weave between them. Yeah. They just term the fibers finish executing its associated function. But yeah. You just tell them to call, and then while they're not both term, you can just have calls. If there's not anything else for it to do, it'll just no-op the call, I guess. But yeah. Good. Yep. Your fiber could still be run because not finished yet. Oh yeah, I know this one wants to make. All right, no, this wants to make sure that both of these still have things to do. But yeah, hey, yeah, that is everything in Parallelism. But yeah, the fiber system is neat. I might take a look at that sometime. Yeah. Then we've got Vibe.d web framework. Very powerful web framework, which, for example, underlines this D language to a website. Ooh! Based on a fiber-based approach for async I/O, Vibe.d allows you to write high-performance HTTPS web service and web services. You can write code that looks synchronous, but which can actually handle thousands of connections async in the background. See the next section for a complete example. Provides an easy-to-use JSON and web interface generator. Has out-of-the-box support for Redis and Mongo that makes it easy to write backend systems that have good performance, and can be used to generate TCP or UDP clients and servers. Yeah, note that the examples in this chapter can't be run online because they'd require network support, which is disabled for obvious security reasons. Alright, easiest way to create a Vibe.d project is install dub and create a new project with Vibe.d specified as template. Ooh! I didn't know that dub had project templates. That's a cool thing. Yeah. Dub will make sure Vibe.d is downloaded and available for building your Vibe.d based project, but yeah. That is cool. And, ooh, there's a book for D web development. Nice. Yeah, let's see what we got here. Using the default build parameters, the main function of Vibe. The app is specified by a special shared static this module constructor. Okay. Yeah, we've got this here. A mod constructor is executed before main and run just once. Vibe.d provides its own main and hides all the event loop and housekeeping stuff from the user code. Neat. 5D uses fibers to implement async IO. Every time a call to a socket would block because we don't have any data for reading, for example, the currently running fiber yields its current execution context and leaves the field for another operation. When the data is available, we just resume execution. Neat. Yeah, that's a really nice way to write IO. Yeah. Yeah, this would just like listen TCP, port 8080, connection, yep. Then this just has like, yeah, and then this just is an echo server. Neat. Okay, yeah. It'll read line, it'll echo it, and then, if you type quit, it'll just finish, yeah. All 5D features make use of fiber... Wait, no. Yeah. No, I didn't read that, yeah. Also, the code looks... Yeah. Or, where did I pick up? Adderall is not treating me nicely tonight. Jesus. Yeah. Yep. Yeah, we've got, like, connection read line, connection write line, but yeah. It might block, but it's transparent. The code looks like it's synchronous and will block the current thread, but it doesn't... The code looks clean and concise, but it still uses the power of async IO, allowing thousands of connections on a single core. That is really fucking cool. I think I might want to use D for like a web service sometime, maybe. Yeah. All 5.D features make use of fiber-based async socket ops, so you won't have to worry about that one single slow MongoDB server connection, blocks your whole application. Make sure to check the example which shows how to implement a simple TCP-based echo server. Yeah. Then for a web server, new HTTP server settings, and settings.port, and you can just like pass in settings and function pointer and foo, but yeah. That'll take an HTTP server request and a server response. Yeah. Use typical usage patterns in the config of different patches. A URL router class is provided which either allows registering get, post, etc. handles using the .get and .post member functions, or registering a custom web interface class which implements web server paths as member functions. Ooh, that's neat. Yeah. URL router, yep. Web interface with a new web service. Gonna take a look at this over there, but yeah. Paths of the custom web interface web service member functions automatically be deduced using a simple scheme. Index will handle /index. Get name will handle the get request /name. Post username will handle post to /username. Then you can also have a path attribute. Okay. Yep. Parameters for post requests will be made available to the function using underscore prefix var names. Okay, so yeah. It's also possible to specify parameters directly in the path itself. Neat. You don't need to pass HTTP server response and HTTP server request as parameter to each function. 5.d statically checks whether it is in the function's param list and just passes it if needed. Neat. Yeah. You can look over here, so yeah. Got like a... Alright, so there's session var for session variables, but yeah. By default, requests to the root path are routed to the index method. Yeah. Yeah, that has like auto contents, then queue string for like all this stuff. Yeah. Yeah, queue. I don't remember what those do. I remember there are different type like rostering or such, but yeah. Yeah. Basically you just put all that in. Yep, then and yeah, you just tell it to res right body, but yeah. And path attribute can be used to customize URL routing. Your request to /name will be mapped to the getName method. Right? So yeah. Yeah, /name will just go to here, yep. Generate header info, item tags by inspecting the request headers property. Neat. Yep. For each key value, rec headers, yep. Ability equals %s%, yep. Format key and value, neat. Contents, yep. And you can just format that through, okay, yeah. And right body. Then we've got post username, right? to that post to username, and that'll just like send the response. But yeah, hello world. Yep, just yep. You can set /hello with get to the hello world function. But yeah, right. And yep, session stories, new memory session store for session var usage. Okay, yeah. Register web interface, router get. Nice, yeah. Lots of cool things. Then Iet Templates, yep. Simplified syntax to write HTML pages. Right. Yeah, yeah. Alright. Basically something like this, okay. Yep, just a templating system, okay. Syntax is indentation aware and closing tags don't have to be inserted. Alright, cool. All Iet templates are compiled and held in memory for maximum performance. Iet templates allows using decode, which is evaluated when rendering the page. Alright, single expressions are enclosed with hash curly, hash brace 1+1, yep, or whatever, can be used anywhere in the template. Whole decode lines are prefixed with dash on their own line, okay? Complex expressions can be used that way, and even functions may be defined that are used to output final HTML. Neat. Alright. Yeah. Then, yep, compiled using Ctfe and have to reside in the views folder in a standard vibe.d project, okay? Yep, then you can just use the render function. Yeah. In a web interface, you would use global render method instead. All D variables available to Iet template are passed as template parameters to render, okay? Then we've got JSON REST interfaces. Let's do the, yep, so JSON web service. If you want to implement following JSON output for HTTP request to API v1 chapter tip. Oh, hello, Liam. Good to see you. Yeah. So we've basically just got this output, so we can find an interface that implements get chapters. Yep. And structs that are serialized 1-to-1. Ooh. 1-to-1 struct serialization. Nice. I like that. Yeah. Actually fill the data structures we have to inherit from the interface and implement the business logic. Okay. Given a... Yeah, how's D different from C? In a lot of ways. D is basically meant to be similar to C and C++, but with a lot of major advantages that make it a lot more usable. God, you're such a nerd. Yeah, basically just adds a bunch more, like, nice usability things, which is good. Yeah. Yep, so given a URL router, we register an instance of the REST class and we're done, so yeah. Yep, register REST interface, got it, yeah. REST interface generator also supports post requests where children of posted JSON object are mapped to the member's function params. Then it can be used to generate a REST client instance which transparently sends requests to the given server. Using the same member functions used on the backend side, this useful code is shared between client and server. Okay, neat. Yeah, let's see. Yeah, we've got like section, chapter here. We've got like the path for get chapters. This will post like title, yep, something like that. Okay, and yeah. Then you've got, yeah, in like our implementation, got like a default provider here. We've got like our internal and like our get chapters interface. Yep. We've got an add chapter, at max reduce pay, generate next highest ID. Then shared static this, just set all that up. That's really cool, but yeah. Ooh, you've got a method annotation for posts. Okay. Database connectivity. Yep, MongoDB and Redis support come directly. Other database adapters can be found on codedlang.org. Okay. Access to MongoDB's modeled around Mongo client. Implementation doesn't have external deps and is implementing using Vibe.d's async sockets. No need to block if the connection has some latency. Cool. Ooh. Yep. Yeah. Redis is implemented with Vibe.d sockets as well. It doesn't have external deps. Central to implementation is Redis database class, which allows to run commands against Redis. Whoops. Didn't mean to click that. Also, convenience wrappers, Redis list, yep. Access list stored in Redis. MySQL support without external deps to the MySQL library can be added using MySQL native, okay. Supports Vibe.d non-blocking sockets too. And Postgres for DPQ2, okay. Based on the official libpq, okay. Yep. Event system for async behavior, yep. There's also DDB, which is a Postgres client with Vibe.d sockets, okay. And no external deps. Lastly, Heroku Deploy. Neat. Yeah, yep, should compile without error, just for like a prereq, yeah, or using DMD, yep. Yep, so you can just set up the app here, yeah. Heroku needs to know how to communicate with the deployed app, so you use a global port envar, okay. Neat. Inject it into an app, should bide and listen, yeah. Additionally, create a proc file, which is text file in the root directory, declares what command should be executed to start the apps, yep, web, / yep. Then you can prepare, Heroku, all that jazz, we git deploy, build pack. I'm not going to use Heroku, because this isn't super important to me, but yeah. Heroku, yep. Oh, that is 9 o'clock, so I'm going to wrap up, I think, but yeah. Ooh, cogen parser. Yeah, I'm going to quickly look at this, because that's something that's up my alley. I love, like, cogen stuff, but yeah. This example, config parser generated at compile time. Let's assume our program has a couple of config options summarized in a settings struct, yep. Well, writing a parser for this struct wouldn't be difficult. We'd have to constantly update it whenever we modify config. So, we'll do a generic parse function that can read arbitrary config options. Parse will accept a very simple, like, key 1, value 1, comma, key 2, value 2, yep. Same technique can be used for any arbitrary config format. Yep, there's a bunch of readers on sub registry, but yeah. Yep, let's say name is dlang, port 8080 is config, then directly split the config options by command call parse with an individual configuration setting, okay. After all config options have been parsed, the entire config object printed, so yeah. Parse is where the real magic happens, yep, over here, but yeah. First we split the given config option, yep, into key name and value dlang, yep. Yep. Splitting by equals. Switch statements executed with the parse key, but interesting bit is that all the switch cases have been statically generated. Ooh. C tuple of returns a list of all members in the index name format. Compiler detects C tuple of is known as at compile time and will unroll the for each loop at compile time. So yeah. The hence conf tuple of index string of will yield the individual members of the struct object and generate a case statement for each member. Equally, while being in the static loop, the individual members can be accessed by their index, yep, C tuple of IDX, and thus we can assign the respective member the parse value from given config string. Moreover, drop 1 is necessary because the split range still points at the key and thus drop 1 front will return the second element. Okay. Alright. So yeah. Furthermore, toBang type of field will do the actual parsing of the input string to the respective type of the member of the config struct. Finally, as the for each loop is unrolled at compile time, a break would stop this loop. However, after a configuration option has been successfully parsed, we don't want to jump to the next case in the switch statement, and thus a labeled break used to break out the switch statement. Let's look at that. So yeah, we've got this config. Yep, got like a yeah. So like we've got this. Then, yeah, then we call a splitter, then for each we run conf parse, then we've got conf.writeln, yeah. And then we've got this, we've got another splitter among equals, so you have an r front, then r.drop1 to get rid of the key front, but yeah. Drop 1 to get rid of the equal, yeah. Then we can, yeah, we've got a switch, which based on a switch E, so yeah. Static for each, yeah, because it's static we can know its compile time, so yeah. Next field, then conf2 of. Then we've got a, yeah, so we've got a case field dot string of tuple index, yep, value to type of field, yep, then break switch, then otherwise we assert 0 and unknown member name, but yeah. Yeah. I think for now I am gonna wrap up. I am getting a bit tired and I've gone through basically the entire tour, so next time I can actually try to implement stuff in D now that I've seen what the general features are. So let's switch back over to just chatting. Yeah, D is a cool language. There's a bunch of cute little features. This definitely hasn't gone yeah, this words. Yeah, definitely not as big as the Rust book, but still really fun to check through, and I am excited to use D for stuff. Yeah. For now, I think I'm gonna wrap stream up. Just getting a bit tired. Yeah. Let's see who's live. Yeah. Oh, geez, a lot of people are live. Okay. Dude, Lynn, Money, Jules, yeah. Andrew, yeah. Ooh. Bunch of folk. I wonder if there are any other folks doing software game development. Yeah, let me see if there are other folks doing software game dev. And also YouTuber. Ooh, a few folks actually. Ooh, someone's learning Ren'Py. We're gonna go over to them, but yeah, yeah. So I am, yeah, we're just gonna go with soft robo raid. Then, since this is the first time, how about we start it off with a wave? Yeah. Beep 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 beep. And this is gonna be raid Damakuno. Yeah. Thank you all so very much for watching, hanging out, joining in. This has been really fun and neat. I like this language, and I am definitely gonna give it some use. I have a couple things I could experiment with adding to it, but yeah. Tomorrow I'm gonna be over on Nikki's channel. We're gonna be playing more Lego Star Wars. I looked back at my footage from last time, and the bitrate was abysmal, so I decided I'm just gonna join in on her channel instead. But yeah, when you get over to their channel, please do not forget to drop them a follow. But yeah, with that, I think I am gonna rest. My voice really hurts. Wow. But yeah, how about we get this raid started in 5, 4, 3, 2, 1. See you soon.